In this topic, we're going to cover generators. Python generators provide a simple way to create iterators. Generators return an iterable set of items one at a time. To create a generator in Python, we can just define a normal function, but give the function a yield statement rather than a return statement. In a normal function, the return would terminate the function entirely. But with a yield statement, we are instead pausing the function and saving the state and local variable information so we can later continue from that point for future calls. To demonstrate this, let's create our first generator. So we can define generator demo function, n equals 1, and then we could yield n, so not return n, but yield n plus equals 1, so increment n, yield n. Let's do it one more time, increment by 1 and yield n. Let's save this, generators demo.py, and execute it. And we see no output here, which is expected. And a generator function cannot include a return statement, as we just mentioned. Because if we do that, the function will terminate execution instead of pausing execution. So we could create a variable here, test equals gen demo. And we could print this out, execute this. And we can see here that Python is telling us that we have a generator object. And so what this has done here is we've assigned test to be an object iterator, but that doesn't cause execution to start straight away. We instead need to use the next function. And the next function returns the next item from the iterator, which is automatically implemented in a generator. So for example, we could instead print out next of test and execute this. And we can see here that we have the value of 1 because 1 was yielded from this generator. And so what happens if we do this again? So we print out next of test and we execute this. And now we can see on the first execution, we get the value of 1 because of this yield. And then on the second execution, we get the value of 2. And the local variable n isn't destroyed when the function yields. So this state is remembered, which is why we get the value of 2 here instead of getting 1, which is what we would have gotten if this was a return statement. So we can do this again and execute this. We get the value of 3, and we can do this again and execute this. However, now we have an error, a stop iteration error. And this happens because when the generator function terminates, stop iteration is raised automatically for any further calls. And that's why it's easy to use a generator in a loop, because a loop knows to stop when this stop iteration exception is raised. So let's comment this out here. Let's create a second variable, test2, gen demo, to again create a generator. And we can say for a in test2, prints a. We can execute this. And we can see here, 1, 2, and 3 is printed out because of these manual print statements. And then here within the loop, we similarly print out 1, 2, and 3. And the loop knows when it reaches this stop iteration error that it needs to stop looping over the generator. And we've used a loop to print each item in the generator. However, we can also create generator functions with loops. So for example, we might want to perform some XOR operation on a static key. So we could define XOR static key, and we could define this key to be the value of 5 in hex or I in A. So for each character in the string that was passed in, we could yield the character, ORed of that character, XORed with the key. And the ORed function here is just returning an integer representation of the character. And now to use this, we could say for I in XOR static key test, print I, execute this. And here we can see that we've used a generator function to perform a static XOR of the word test with the key of 5. And this is the output here. And we can also create anonymous generator expressions in a similar way as we made anonymous lambda expressions in the Python 101 for Hackers course. And the syntax is very similar, but we use round brackets instead of square brackets. So we could make the same function, XOR static key 2 equals char forward of I, XORed with 0x5 for I in test. We can print this out, XOR static key 2. And we can see, as expected, we now have an anonymous generator object here. And we can print out the values. We see Q, as expected, Q. And we can keep doing this, printing out the next value. Or we could also just continue this in a loop as well. To similarly print out the same XOR encoded values. And these are simple examples. However, generators are very useful to use for memory intensive processing or reading of really large files. Because generators use lazy execution. They only produce items when they are asked for, rather than computing the entire sequence at once, which is what we saw as part of this demonstration. But that's it for now. And in the next lesson, we are going to cover serialization.